Okay, sorry about that. My phone overheated. So I'll pick up where I left off. So then so the roof, we have 2x plus 1. And on the wall, I have x plus 2. Okay? Now, I'd like to point something out here. That's why I drew this one up here. So we see that we have this line here drawn, and we have this line here drawn, right? So there's a line separating these two, and there's lines separating these two. This line continuing down also is separating these from those. So what I notice is that some of the lines that I draw don't separate shapes that are different, but are separating two shapes that are the same. And then some lines that I draw are now changing from a shape that was, say, a square to one that's more like a long rectangle. So this is an important point right here, because that line right there is changing from this shape over to this one, or from this shape over to this one. So that's an important line, or important spot in my chart. And I have the same thing over here. This is also an important point because these shapes are the same. So that line is just kind of letting me know how many of these I have in here. But this line is now saying I'm going from an x squared to an x, or I'm going from an x here over to a 1. So these two lines are kind of important to notice because they are the ones that separate our shapes, and our shapes are added together if they are the same. So this can be added to these because they're the same. So I got to find out where are these shapes and where are these shapes, or those, whatever. So the question is, how does this line relate to this equation? Where is that line at? And how does this line relate to this equation? Well, up here you see that here's where my 2x is, and here's where my 1 is. So that's 2x plus 1. And here's where my x is, and that's plus 2. So what you might notice is the separating line from this shape to this shape is right where that addition sign is. And the separating line for this shape to this shape is right where that one is. So if I come down here, I know that I'm going to be separating and creating new shapes anywhere I see an addition sign. So this shape is going to be different than that one, and this shape's going to be different than that one, and this one's going to be different than that one, and that one's going to be different than that one. So now I've got 4 boxes. So I say, okay, x times 2x gives me 2x squared, because that's the shape of them, they're squares. X times 1 gives me x. 2x times 2 gives me 4x. And 2 times 1 gives me 2. Now what I'll notice is, just like this and these are the same shapes, these diagonals will always be like terms. So I'm always going to be able to add these diagonals together. So I don't have anything the same as that. So it's 2x squared plus 5x plus 2, just like that. Okay? So doing this generic rectangle, by the way, this is called generic rectangles. And it's called generic rectangles because it's not all of the specific lines that are inside of this, right? We don't draw this line, we don't draw this line or this line. I don't draw this line, I don't draw that line. All I'm doing are 4 boxes. I've got this box, this box, this box, and this box, and it stands for all of them. So these are called generic rectangles, and these would actually be called algebra tile drawings, if you're looking for the names here. And so this is a way that I can multiply binomials together that will allow me to find the quadratic, which is based on the area of a rectangle. Now, I mentioned a minute ago why this method is no good because of this right here. So now we're going to take a look at that and see, how does that work? Does this method allow for that? So I have x plus 4 times x squared plus 3x plus 7. Just like that. So what I'm going to do here is, I know that I am multiplying two numbers together, right? Every time, I know I'm making the area whenever I multiply two numbers together. So this is going to be area for my rectangle here. So here's my rectangle. Okay. Again, it doesn't matter where I put them, but since I did the long side like this, I'm going to go ahead and make that be the top. So this x plus 4 is going to go on my wall of my house. And this over here, x squared plus 3x plus 7 is going to go on the roof. And I just mentioned a minute ago, anywhere I have an addition sign is going to be the break for a brand new shape. So I'm going to draw my lines in there. I have an addition sign there, so I draw my line like that. So the only difference from what we did before in this one is before I had 4 boxes, this time I have 6. And I have 6 because I have 3 going across instead of only 2. So x times x squared gives me x cubed. And there might be a little mini lesson there for your students if they don't remember that. 3 times x x times 3x gives me 3x squared. X times 7 gives me 7x. 4 times x squared gives me 4x squared. 4 times 3x gives me 12x. And 4 times 7 gives me 28. And what I mentioned before is these diagonals will always be your like terms. So right there are like terms. And that's another way that students can check. If these are not like terms, they must have done something wrong. And usually they've forgotten like a square or something like that. So I don't have anything that's in common with the x cubed, so that's that shape. Then I have 4x squareds plus 3x squareds, which gives me 7x squareds. I have 12x plus 7x, which gives me 19x, and then plus 28. So one of the many reasons I like the generic rectangle way more is that when this problem comes up, I don't have to teach them something different. I can teach them the exact same thing that I've been doing, and the only difference is the box just gets bigger and bigger and bigger. So it doesn't matter. I even give my students 3x3s, right? So trinomial times a trinomial. The box just keeps getting bigger. Doesn't matter. Okay? All right, so that's it for today. We're gonna, by the way, this is part of your project that you're doing. So you guys can now do this because there's a thing in there about multiplying binomials and what you understand about generic rectangles and the area and that sort of thing. So you're demonstrating what you know about multiplying binomials and how it relates to base 10 or algebra tiles and that sort of thing. So you now can do part of your project because this is part of that product that you're doing. Okay, have a great weekend. I'll see you guys on Tuesday.